What is that we discussed in the earlier class? Very good. Not Raabes. Raabes I will take it now. Right? Limit comparison test, ratio test and root test is over. When the ratio test fails and un by un plus 1, whether un plus 1 by un or un by un plus 1, this ratio should not involve e. When the ratio does not involve e, please give me that duster. When the ratio does not involve e and the ratio test fails, then we will be taking the help of Raabe's test. Now let me write it what that Raabe's test says. Raabe's test. It's so simple. If sigma un is a series of positive terms, always we will be writing that until and unless we start alternating series. We will be every time writing this series of positive terms. And when the ratio test fails, you are already available with un plus 1 by un. Just you do reverse, that is un by un plus 1. Whatever result has come, just to take the reciprocal. Subtract 1 from that. Whatever this comes, you multiply n to this. And then apply limit as n tends to infinity. If this limit comes equal to some number L, then, okay, these are all conditions. Then, first bit, conclusions now. Sigma un is convergent if L is greater than 1. How you remember that? Because it is reverse ratio, reciprocal ratio, we are having opposite condition when compared to ratio test. So it's L greater than 1. Second bit is a divergent if L is less than 1. Number 3, again the same thing. The test fails. Oh, so nice. Fails when L is equal to 1. So everybody understood this one? Let us take up a problem where we will apply ratio test first. Then if it fails, we will take the help of Raabe's test. Do you remember that ratio test should be applied when factorial comes? Or factorial comes, keep in mind this is very important point. Factorial comes or like factorial concept. Like what do I mean by like factorial? I will make it clear. That is, when you say factorial, n factorial will be equal to 1 into 2 into 3 so on up to n. Okay? So that so on concept is there. You are starting with some factor, you are taking so many factors, so on like that. Now this is the concept of a factorial. If we are using like factorial, I mean 1, 3, 5, 7, so on up to suppose 2n minus 1. What I am doing here, I am not specifying how many terms will come into this. I am specifying that this is the format, but it will end up at this one. So 1, 3, 5, so on up to 2n minus 1. Can I write it as 2n minus 1 factorial? No. But I can express this in terms of factorials, because if it is like this, I can multiply 2, 4, 6, so on. I can divide with 2, 4, 6, so on. I can take 2 common and I can express in the form of a factorial. Let us not enter into that one. I will say just simply that this product is like a factorial. This is a factorial, this is like a factorial. So if un is containing n factorial or terms like factorial, then we will be using ratio test. Now let us do a problem. See here. Test the convergence. Test the convergence of the series sigma 1, 3, 5 so on up to 2n minus 1 divided by 2, 4, 6, so on up to 2n. First of all, try to understand very carefully that what will be the expansion of this type of summation. It's an infinite series. Be careful about the expansion. Now, I will not write that expansion as a expansion as a part of the solution. I will just make you clear about how this is working. So this is equal to, can anybody say what is the third term of this? This is un. This complete is un. This complete is un. What is u3? Third term. How do you get the third term here? 1, 3, up to where you have to go? Up to 2 into 3 minus 1. That is 6 minus 1, 5. So it will be 1, 3, 5 divided by, when n is equal to 3, it is 6 here. So it will start with 2, end with 6. Plus, what is the second term of this one? 1 into 3 by, what is the first term of this one? 1 by 2. I can assume that you can tell what is the fourth term next. Now try to understand the difference between this type of series and this type of series. Sigma n into n plus 2 divided by 2n minus 3 or 2n plus 3 into 3n plus 4. That's equal to, what is the expansion? What is the second term of this one? N value 2. What is the second term? N value 2. So 2 into 2 plus 4. 2 plus 2, that is 4. Don't multiply. That's not required. 2 into 4 divided by 2 here. So it is 7 into 2, 3 is 6. 6 plus 4, 10. Plus. Tell me this is second term, no? What is the first term? 1 here, 3 here. Am I right? 1 into 3 by substituting n value 1. 5 into 7. Just tell me one term more enough. Okay. N value 3. 3 into 5 divided by, substituting n value 3. 6 plus 3, 9. 9, 13. Right? Am I right? 13. The very special point to be noted is that this series and that series are different in very fundamental point, that the number of factors are fixed here. Only 2 factors in the numerator, 2 factors in the denominator. Because there is no so on concept here. It's just n into n plus 2 divided by this one. So every term will have only 2 factors. Whereas if you see here, it is so on concept. So on. So first term is having 1 term in the numerator, 1 term in the denominator. Because of this so on concept, number of factors are 2 here, 2 here. It need not have same number of factors. I can write one more time here, for example. Then 2 factors in the numerator, 3 factors in the denominator. 3 factors in the numerator, 4 factors in the denominator. So the number of factors are not fixed. It's going on growing. So if this point is clear to you that this series and this series are totally different, then you can understand the next coming concept very easily. The point is that for this type of series, it's a polynomial. Yes, am I right? It is n square plus 2n. It is a second degree polynomial. If you expand this, it is also second degree polynomial. Second degree polynomial by second degree polynomial. Okay. Normal idea is to apply limit comparison test, but there is a shortcut idea. I will tell you after this one. Shortcut idea. That shortcut idea to be used when the degrees of the polynomials are same. That's a very shortcut idea. That I'll tell you afterwards. So right now back to the point. This series is different. Whereas coming to this series, the number of factors are increasing, and the concept of factorial is used. Concept of factorial is used. Some way it is related to factorials. Therefore, we will be using ratio test. Factorial or like factorial. We will be using, come on, ratio test. Now, so simple, systematically I'll write it. Shall I skip some of the terms by calling this as sigma un and then un will become this one? Shall I write it directly un? So what is un in this case? Here un is equal to 1.3, you don't tell, 1 into 3 into 5, so on up to divided by, so on up to 2n. This is un. Therefore, un plus 1. Simple idea is, if it is u3, we are talking about u4. If it is u3, we are talking about, if it is u10, we are talking about u11. Did you note that when I have expanded that in the form of a series, that factors which are coming in some term, that same factors are coming in the next term, but extra two more factors are coming, one in the numerator, one in the denominator. Can you make a guess what will come here? That is 1, 3, 5, so on up to 2n minus 1. This will however come denominator, that 2, 4, 6, so on up to into one more factor will come here, one more factor will come. You have, listen my point, and listen, you have two options now. One option is to substitute n as n plus 1. That is ordinary option. The best option is, what is the difference between them? 2. Just add 2 to this one. Next one will be 2 more, because that same sequence is getting continued. So what is the next one? 2n minus 1 plus 2. So that will become, okay, it is 2n. Next will be difference how much? 2. So next it will be 2n plus 2 over this is un plus 1. Therefore, un plus 1 by un. Now I think you are not okay, you are not at very basic level that I should write complete un plus 1 and then I write un. No need. So what is in the numerator? Un plus 1. Means this complete is to come here, this complete. I need not copy. It is 1 by un, means un is in the denominator, so it will be getting reversed. So what should I multiply now? This comes in the numerator, this becomes numerator, this becomes denominator. So 2, 4, 6 on 2n will come, 1, 3, 5 so on up to 2n minus 1 will come. This part here and this part here gets cancelled. And this part here will get cancelled with this part. So what is the net result? So it is saving time, saving so many things. Follow? So just think, this I have copied, this I have reversed. Simply this un plus 1 will be having 2n plus 1 by 2n plus 2. This will remain. So what should I write now? Net result 2n plus 1 by 2n plus 2. Now I will make a small change. That is, I will apply the limit as n tends to infinity here itself. Okay? So this is what now? Limit n tends to infinity un plus 1 by un plus 1 divided by un. Okay? Following? Limit n tends to infinity. What should I do now? I have to calculate the limit. To calculate the limit of this function, take the highest power comparing from numerator and denominator. Select the highest power, divide with that highest power, numerator and the denominator. What is highest power? N only. So I will divide numerator and denominator by n. So what I will get? That's equal to limit n tends to infinity 2 plus 1, or else I will write it one step, just one step I will write it, 2n plus 1 by n divided by 2n plus 2 by n. Are you all clear up to here? Why you have divided with n? The highest power compared from or selected from numerator and denominator is only n. So I divided the numerator and denominator with the n. Limit n tends to infinity. Come on, 230. 230 is not listening. 230 is not even listening even now. You're 230, no? You stand for some time. Stand. You'll be active now. Come on. Limit n tends to infinity. Chalo, come on. What should I do? I have to separate. Chalo, come on. Tell the next step. You do tell now. What is this? Simplification. Do it. 2 plus 1 by n. 2 plus 2 by n. That's equal to limit n tends to infinity. Some formal steps I'm writing. This is 2 plus 0 divided by 2 plus 0. This is 1 and limit is applied to constant. Then it is constant only. Limit n tends to infinity 1. Because it is not at all involving n, this n is not done anything here. We will not send that n anyway. So it is just 1. Limit of the constant is constant itself. What is this one? It is the limit of this one. Therefore ratio test fails. Shanmukh, listening? So what is un plus 1 by un? Just 2n plus 1 by? You reverse it, it will become 2n plus 2 by? Is it involving e? No. Test failed, ratio test. Ratio test failed and it is not involving, that un by un plus 1 is not involving e. Therefore, we take the help of Raabe's test. We now apply Raabe's test. Understood up to here? Now don't take the screenshot. I will take it for you. Is it okay? Yes, enough. Good. Okay. Huh? You come and stand here. Come. That tab is disturbing you. Really, you come. Come and stand here. Huh? No, I take it. No need of you all. Chalo, stop. Listen, concentrate. Now, you tell this one, I'll make you sit. What is the calculation? No, not you. He is telling. Don't know. Don't stand in the corner. There you go. If you tell me, I will make you sit. Un by minus 1 n. That's equal to limit n tends to infinity. N into. What is un by un plus 1? I think it is 2n plus 2 by 2n plus 1. So it is 2n plus 2 minus so okay fine, this comes this side. Baby steps let us avoid. So 2 and 2 gets cancelled. 2 minus 1, 1. So it is 1 only in the numerator. That one I am multiplying with n. Very good. N by? How should I find the limit? Same style here as we have done. So we will divide with n. N tends to n by n by. So that is now equal to limit n tends to infinity 1 by 2 plus 1 by n. Very good. It is 1 by 2. Having a doubt? Oh, so nice. You come and sit down. Good, good, good. That much loudly he said because he is standing at the corner. That's what I felt. Who is saying this much loudly? Right, very good. 1 by 2. This 1 by 2 is less than 1. One beautiful point I will tell you. One of the student in our college previously asked to the teacher, I got 1 by 2, but how should I decide if it is less than 1 or greater than 1? This happened real scene. Leave it. Now you are all okay. 1 by 2 is, but you may get a doubt. Less than 1 means convergent or divergent. I said it is very good. Therefore, by test. Given series is divergent. This will be my style to tell that the problem is over. This indication over, understood? So when to apply Raabe's test, how to apply, how to get it, how to decide, everything is clear. Next comes very important point. Actually we have done 4 tests. You know, all the 4 are over. Sometime back, do you remember, when the degree is same, polynomials are having same degree, ordinary way is to go for limit comparison test. Polynomial, same degree. So what should we do normally? Limit comparison test. But better don't do that. There is an alternate. That alternate is like this. Oh, I didn't take it, no? So this is still remaining. This space is remaining. Chalo. I didn't take the photo, no, I'll take it from the video. Screenshot is possible from the video. Okay, I should think that you are very excited and you are talking with your neighbors regarding this. I'll assume this. So in the earlier part, first part actually deals about definition of sequence, definition of infinite series, all these things. First part. Part 2 deals about geometric series. No, geometric series was over in part 1. Part 2 deals about ratio test, limit comparison test, all these things. Part 3 is about Raabe's test. Just Raabe's test is in part 3. Now, presently I am starting part 4. In this part 4, we will finish all the remaining concepts. In part 5, we will devote that part 5 for problem solving session. So, now in this session of just maybe maximum 5 minutes, we will touch 2 things. One is a shortcut for divergence. Keep in mind, this shortcut will tell you only regarding divergence of an infinite series. And then in this second part, we will discuss alternating series, concept of absolute convergence, and concept of conditional convergence. Coming to this shortcut, if sigma un is a series of if you get a doubt, directly ask me. Don't ask to the neighbor because he don't know. I think I know more than your neighbor. So don't ask to the neighbor sitting beside you. Ask me. If sigma un is a series of positive terms and Don't do anything. In limit comparison test, un by bn, in ratio test, all these things are clear. Here, just pick up this un, find the limit as n tends to, if this limit is not equal to 0, if it is equal to 0, you can't decide it, anything, no conclusion. But if this limit is not equal to 0, then sigma un is divergent. This is very special shortcut. This is 100% applicable in the case when un is polynomial by polynomial, both are of same degree. I'll just take up this example. Test the convergence of the series sigma 2n plus 1 by 3n plus 4, suppose 1 to infinity. Solution. No need of applying limit comparison test. If you apply, it will come, but it will be unnecessary lengthy. So just a simple, here what is un? Here un is equal to 2n plus 1 divided by 3n plus 4. What is now limit n tends to infinity, un, no other thing, just un. So un is this much. So what is that? Limit n tends to infinity, 2n plus 1 by 2n plus 1 divided by 3n plus 4. How do you calculate this limit? Simply just divide that both numerator and denominator with n. So that's equal to, shall I write one step less, that is 2 plus 1 by n divided by no need of changing, less than 0, greater than 0, less than 1, or nothing, not equal to, therefore sigma un is divergent. Over. I hope you are all clear about this shortcut for the divergence. Now comes very important concept, that is alternating series. A series whose terms are alternately positive and is called alternating series. What is an example? 1 minus 1 by 2 plus 1 by 3, so on. It's an example. It starts with positive term, it may also start with a negative term. This is an example. What is the short form for this example? Sigma. This 1 by 2, 1 by 3, 1 by 4, 1 by 1, they all come from 1 by n. This plus minus will be adjusted with minus 1 power n minus 1. N is equal to 1 to. This is an example. This is the format of an alternating series. Are you all clear up to here? Okay, fine. So we will end up here. We will discuss conditional convergence and absolute convergence in the next class. Because it's over, time is 12:50 now. Okay?